Thank you. Hello. Next slide, please. So that's me. Okay, next. So here are 3 examples of a passenger train, high-speed train, and freight trains. It's on the same line, the same huge variation in the energy consumption of these trains on these lines. Hello? Yeah.
Switch your, take another one. With the table, the microphone on the table, change it. Battery issue.
Okay, better? It means that if you're running on the same tracks and you have such a difference in consumption, there is no return on investment for automatic train operation or whatever eco-driving. You need to have measurement to be invoiced correctly for your real consumption. Next slide. How can we do it? First, you have sensors or transformers measuring current and voltage. Then you need to multiply and integrate. Then you have the energy consumption, also during braking. Then we add the locations, because you need to know where consumption took place, as you need to be able to send it to the right infrastructure manager on which grid the consumption took place. Next, then this is altogether called an onboard energy measurement system, which is standardized in the 50463 series of Senelec and now in the 62888 of IEC. So railway undertakings operate trains. Trains can have an onboard energy measurement system. That one sends the data system on ground. It's going up and down. Then data goes to exchange. In exchange, we're looking what were the GPS positions, and then send the data to the country where the consumption took place. Then we come in settlement. Settlement will have different functions. Next click. So first is validate, estimate the metering data. For that, we receive data from the railway undertakings. This can be your request of a train run, but also energy market, what was the consumption in the different substations. With that together, we can validate, estimate, but also allocate to the right consumer who has been consuming, and they can have free choice of supplier, so the data can go to the infrastructure for the grid fee and to the energy market for the consumption. It can be that it's still the infrastructure manager delivering the energy, and all the contract is passing by that infrastructure manager. You have the invoice. Next slide. So an overview in time of regulation and standardization. On the left you see the EMS, the meter on board, the communication to ground, the DCS collection on ground, and then the settlement, the handling of the data on ground. And now we're going to start history. 2007 was the first standard. 2009, a first UIC leaflet regarding the handling of the data on ground. 2011, the first TSIs, but the Senelec standard was still not yet ready, so they just copied in parts of the Senelec standard in an appendix of the TSI. Then 2012, the full standard was published, 5 parts, introduction, the energy measurement function, then the data handling system on board, the communication, and the last part was conformity assessment. 2014 was a new series of TSIs with on board, it was mandatory on new, renewed, upgraded vehicles. The communication to ground was not yet defined exactly, so it was regarded an open point between 2 TSIs, and the energy TSI had the data collection on ground. The rest was in the Commission regulation saying that 2 years after the closing of the open point, you shall have a DCS on ground, and you shall have settlement able to exchange, validate, and allocate, and taking into account the legislation of the energy market. Then we are in 2017, following the open point request from Commission to ERA, ERA to Senelec. Senelec has adjusted the standard and has now a communication protocol for the communication between board and ground. That's 2017. Then 18, this was taking over in new commission regulation and a new TSI updates. So you have to follow that one. And then we come to the dates. In a DCS will only become mandatory next month, but the settlement further on became mandatory July 2020. It's a bit an oddity, but it was that way published. Then we are 2020, and then there is an update of the UIC leaflet. Now it's in IRS 9930, updating the role model and the settlement on ground. And then at the end, we have also 1 month later a sector declaration, and I will come back to that point also later. Next slide. So 9930, which is the role model on how metering should function, what are the different roles, how should data be allocated, how should it be transmitted, who should do what. So it's all the task responsibilities. So it has the actors, that are the stickmans, and the functions, that are the blocks. And then the big black lines are the data flow between the functions. If you have the presentation afterwards, you can just click on that IRS 9930 and you will have the link to get it free from the ETF shop. And if you want to join the project, it's still possible. So everything is published, but we are now in a maintenance phase. So it has to get up running everywhere. So that's why we have this maintenance. Okay? The sector declaration has been approved by AllRail, CR, EIM, EPTOLA, ERFA, FEDEC Rail, NB Rail, and UIC. So not UNIFE, again. He has left, so he should have been here. It has commitments for the RUs and for the IMs. There were also two aspects where we wanted change in the regulation. One is that there were deadlines that were too short, but Commission refused to adapt it, so it will remain the short deadlines. And the second point, we had a meeting with UNIFE this time a few weeks ago, and we have a joint proposal now towards ERA, and we hope it will become part of the next TSI revision. This is on trains with existing transformers, where it's much cheaper if we could keep these transformers, but they are not tested according to the 50463. They are tested according to standards of the electricity market. So you can't prove they are accurate at 1% or 5% of the current or at temperatures low or high. And there we have a compromise now, and hopefully ERA will put it into the, will propose it into the Commission implementing regulation that will introduce the changes in 2022. Okay, next slide. So these are the commitments, infrastructure manager and RU. So RU has a commitment on installing EMSs. We have put some values how much should be installed. If it's a new installed EMS on a new train, then it shall be fully compliant. If not, the non-compliances shall be stated. All new renewed EMS shall send the data as soon as possible to ground, and RU shall be able to deliver the train compositions. If we don't have train compositions as IM, we don't know who has consumed, and we can't make the link with an onboard energy meter because they use the European vehicle number as identification. IM shall provide the DCSs as requested and will use the deadlines from that IRS on the further sending of the data and use the protocols of that IRS. The IRS 9930 is using the same protocol of the same data blocks as in the 50463. So the same data block is used for communication from board to ground and further on ground. And IM shall enable a pragmatic approach to increase the possibilities of the RUs in the electricity purchasing strategy. As you see, this is a political sentence, and all relevant information is publicly available. Next slide. So we have a framework on energy metering and settlement. So now there is also return of investment possible to the RUs in consuming less energy. How can we, as infrastructure manager, help them? That will be the next slide. Can we send information in front to, for instance, avoid an unnecessary stop, an unplanned stop? How can we do that? So this is an example from Switzerland. So a train is running on the normal way, so you have a tight run going to the max speed, but then you have a double yellow and you have to stop, and you're entering a little bit too late in the station due to that unplanned stop. Just remember the values, 350 and 651. Next click. So you see, by avoiding this unplanned stop, there is a huge decrease of the consumption, but also the train is arriving in time and not too late. So by running too fast or at maximum permitted speed, you're arriving later and consuming much more. But an RU needs to know this, the driver needs to know this, and he doesn't have to do it with a lot of tables and things like that and looking outside. He should get the right information on a tablet or on a screen in the cap. Next, yeah. So we published an IRS 9940, so also from UIC, and it has a protocol called the Sphera protocol, and it enables communication from traffic management towards a tablet PC on board. Why did we develop a separate standard? Because in Shift2Rail there was the ATO project ongoing, but that was just for ATO and just for ATO over ETCS. And we were afraid that we would losing too much time if we would wait. But they've understood in the meantime, and they're going to also adapt in the ATO over ETCS to not only ETCS, and also to adapt it for driving advisory systems. And we are now having joint meetings with them to come to a joint standard, but that will be for the 2027 TSI. So two ways of communication: direct one from traffic management system towards the tablet on board, or by communication to a server of the railway undertaking or a server of a DAS supplier, and then to the DAS on board. And DAS is driving advisory system. Next slide. So how does it work? Each DAS has its own optimization algorithm. It sends feedback towards traffic management system. Traffic management system then calculates, are there conflicts? If there are conflicts, sends advices. Advices come back in a train path envelope. A train path envelope says you have to pass on that point, moment, and that moment. So it gives a time span where you can pass. It can also adjust the arrival time in stations, because otherwise you will have a conflict. If it's better to arrive 1 minute later, it's better to give that information. Next slide. And that's the last slide. So we're here in Toulouse. We're in the panel regarding the Green Deal. I'm just wondering how many of you has been coming by train? A lot, but for a railway, we're here on a railway meeting. It should have been more. Who is coming by plane? It seems to be nearly the same or a little bit more. And I just compared the values via Eco Transit from Eco Passenger from UIC. It's a huge difference on the travel from Brussels to Toulouse, and it's not that much difference in time. We came from Brussels yesterday, but you're just working one day in a comfortable seat in an SNCF train, and you're arriving here in the city. So why to go to an airport, wait there, go in, have such a table of 20 centimeters if you're lucky, and again a transport here, and maybe it took 4 hours less, but we have been working a full day, so we haven't lost any time. So, thank you very much.
Thanks a lot, Bart. Thanks a lot. Was